Good evening, and welcome to Cozy Sleep Time. Get comfortable and take a slow breath. Let your body relax more and more. Tonight's story is about the salmon. Simply listen or let your mind drift. There is no need to focus. Let the quiet story begin. Tonight we explore the remarkable life of the salmon, a fish that undertakes one of the most extraordinary journeys in the natural world. Salmon begin their lives not in the vast ocean, but in the shallow, gravel-bottomed streams of freshwater rivers and creeks. These streams are often located high in mountainous regions, far inland from the sea. In these cold, clear waters, female salmon dig nests called redds in the gravel bed. They use their powerful tails to fan away debris and create a depression in the stream bed. Into this carefully prepared nest, the female deposits thousands of tiny, orange eggs. A male salmon then fertilizes the eggs with his milt, and the female covers them with gravel for protection. The eggs are small, each about the size of a pea, and they require cold, oxygen-rich water to develop. Over the next several weeks, the embryos grow inside the eggs, nourished by the yolk sac. The temperature of the water determines how quickly they develop, with colder water slowing the process. When the eggs finally hatch, the young salmon emerge as alevins, still carrying their yolk sac for nutrition. These alevins remain hidden in the gravel, relying on their yolk sacs for sustenance while they grow. Once the yolk sac is absorbed, the young salmon emerge from the gravel as fry. At this stage, they are only about 1 inch long and must begin feeding on tiny insects and plankton. Fry are highly vulnerable to predators, including birds, larger fish, and aquatic insects. Their survival depends on finding shelter among rocks, undercut banks, and submerged vegetation. As they grow, fry develop distinctive dark vertical stripes called parr marks along their sides. These markings provide camouflage in the dappled light of the stream, helping them hide from predators. During this freshwater phase, young salmon are called parr, and they spend months to several years in the stream. The length of this freshwater stay varies by species, with some staying 1 year and others up to 4. Parr feed actively on aquatic insects, insect larvae, and small crustaceans to build strength for the next stage. Their bodies gradually undergo changes that will prepare them for life in saltwater. They begin to lose their parr marks and take on a silvery coloration, a process called smoltification. At this point, they are called smolts, physically transformed and ready to migrate downstream. Smolts sense the changing length of daylight and the increasing flow of spring runoff, which triggers their journey. They ride the current toward the river mouth, navigating through estuaries where fresh and salt water mix. This transition zone allows their bodies to gradually adjust to the higher salinity of the ocean. The journey from freshwater stream to the open sea is dangerous, with many predators lying in wait. But those that survive this passage enter the ocean and begin a completely new phase of life. Upon reaching the ocean, salmon enter a world of immense abundance and vast open water. The transition from freshwater to saltwater triggers a series of profound physiological changes in their bodies. Their gills and kidneys adapt to regulate the higher salt concentration of seawater, maintaining their internal balance. In the ocean, salmon find a rich and plentiful food supply that allows them to grow rapidly. They feed on a diet of smaller fish such as herring, anchovies, and sand lance, as well as krill and squid. This protein-rich diet fuels extraordinary growth, transforming the small smolt into a large, powerful fish. Salmon are cold-blooded, their metabolism driven by the temperature of the surrounding water. In the productive waters of the North Pacific and North Atlantic, they gain weight quickly, sometimes tripling their size in a single season. Their bodies become sleek and muscular, built for endurance and speed over long distances. Oceanic migration patterns vary by species, but most salmon travel thousands of miles across the open sea. Some species, like the sockeye, migrate in huge circular routes, following ocean currents and food sources. Chinook salmon, the largest of the Pacific species, have been known to travel more than 2,000 miles from their natal streams. Salmon use the Earth's magnetic field as a natural compass, sensing its lines of force to navigate the open ocean. This remarkable navigational ability allows them to traverse vast distances with astonishing accuracy. During their time at sea, salmon are pursued by many predators, including sharks, seals, sea lions, and orcas. They must remain constantly vigilant, using their speed and keen senses to avoid being captured. Their silvery coloration provides camouflage in the open ocean, reflecting the light from above and making them hard to spot. Salmon travel in schools for protection, reducing the chance that any single fish will be taken by a predator. The ocean phase of the salmon life cycle lasts from 1 to 7 years, depending on the species. Atlantic salmon typically spend 1 to 4 years at sea before returning to freshwater. Pink salmon have the shortest ocean residency, returning after just 18 months. Chinook salmon may spend up to 7 years in the ocean, growing to massive sizes of over 100 pounds. Throughout their ocean life, salmon accumulate energy reserves in the form of fat and muscle tissue. These reserves are critical, as salmon will stop eating entirely once they begin their return journey to freshwater. They must store enough energy to sustain them during the long migration upstream and the exhausting act of spawning. The longer salmon remain in the ocean, the larger they grow and the more eggs the females will carry. A large female, Chinook, may hold as many as 7,000 eggs, each one a potential new life. Ocean survival rates are low, with natural mortality claiming many fish each year. But the ocean is also where salmon reach their full potential, growing from a tiny smolt into a magnificent adult capable of completing the cycle. After spending months or years at sea, an internal clock tells the salmon it is time to return home. This homing instinct is one of the most powerful and remarkable behaviors in the animal kingdom. Salmon return to the exact freshwater stream where they were born, often traveling thousands of miles to reach it. They navigate from the open ocean toward the coast with guidance from the Earth's magnetic field. As they approach land, salmon switch to olfactory cues, using their extraordinary sense of smell to identify their home stream. Each stream has a unique chemical signature, a mixture of dissolved minerals, plant compounds, and organic materials. Salmon imprint on this chemical fingerprint when they are young smolts, and they remember it for the rest of their lives. This sense of smell is so precise that salmon can distinguish their home stream from others that are nearly identical. The return migration is timed with precision, typically occurring in late summer or autumn when river conditions are favorable. As salmon enter freshwater, they undergo dramatic physical changes in preparation for spawning. Their silvery ocean coloration gives way to deeper, more vivid hues, often turning bright red, green, or copper. Males develop a hooked jaw called a kype, which they will use to compete with other males for access to females. Their bodies become deeper and more compressed, and their skin thickens. These changes are driven by hormones that also shut down the salmon's digestive system. Once salmon enter freshwater, they stop feeding entirely and rely solely on stored energy reserves. The upstream journey is an arduous test of strength and endurance against powerful currents and obstacles. Salmon must leap over waterfalls, navigate rapids, and push through shallow gravel beds to reach their spawning grounds. They can jump as high as 12 feet to clear obstacles, using their powerful tail muscles to propel themselves upward. Along the way, they face predators including bears, eagles, otters, and humans, all of which take advantage of the concentrated fish. The migration can cover hundreds of miles inland, with some salmon traveling as far as 900 miles upriver. The Columbia River system alone sees Chinook salmon travel over 500 miles to reach spawning grounds in Idaho. Salmon do not all return at the same time. Some populations, called spring runs, enter rivers months before spawning and hold in deep pools until conditions are right. Other populations, called fall runs, return later and spawn soon after arriving. This staggering of return times ensures that spawning grounds are used efficiently over a longer period. As salmon swim upstream, their bodies begin to deteriorate. Their muscles break down to provide energy. Their skin becomes worn, their fins fray, and their immune systems weaken. But the salmon push onward, driven by an unrelenting biological imperative to complete their journey. The closer they get to their birthplace, the more determined they become, pressing forward despite exhaustion and injury. Finally, after weeks of struggle, the surviving salmon arrive at the gravel beds where they were born, ready for the final act of their lives. When salmon finally reach their spawning grounds, their bodies are worn and their energy nearly spent. Yet they still have enough strength for the most important act of their lives, the creation of the next generation. Female salmon begin the spawning process by selecting a site with the right gravel size and water flow. They prefer gravel that is clean and well oxygenated, free of silt that could smother developing eggs. Using her tail, the female digs a nest called a redd, a shallow depression in the gravel bed. This is physically demanding work, requiring hundreds of powerful tail thrusts over several hours. As she excavates, the current carries away loose sediment, leaving clean, porous gravel behind. While the female digs, one or more males compete for the right to fertilize her eggs. Dominant males fight aggressively, using their hooked jaws to bite and push rivals away from the female. These battles can be violent, with fish sustaining torn fins, bruised bodies, and even broken bones. The largest and strongest males typically win access to the female, securing the opportunity to pass on their genes. Smaller males may attempt to sneak in and release their milk quickly when the dominant male is distracted. When the female is ready, she settles into the redd and releases her eggs into the depression. The male immediately moves beside her and releases milt, a fluid containing millions of sperm cells. The milt spreads through the water, and fertilization occurs externally as the sperm and eggs meet among the gravel. After fertilization, the female immediately covers the eggs with gravel, using her tail to sweep stones over them. This covering protects the eggs from predators and keeps them in the cool, oxygenated flow of the stream. The female may dig several more redds upstream, laying batches of eggs in each one until she is empty. A single female may deposit anywhere from 1,000 to 7,000 eggs over several nests. Once all her eggs are laid and covered, the female's role in reproduction is complete. By this point, the female is severely weakened, having used nearly all her remaining energy for digging and spawning. The males are also in poor condition, their bodies battered from fighting and their energy reserves depleted. After spawning, both male and female salmon are exhausted beyond recovery. Their immune systems have broken down, their tissues are deteriorating, and they are vulnerable to infection. In nearly all Pacific salmon species, death follows within days or weeks of spawning. This programmed death is called semelparity, meaning the fish spawn once and then die. Atlantic salmon are an exception, as some survive spawning and may return to the ocean to spawn again in future years. For Pacific salmon, the end comes quickly as their bodies literally fall apart in the stream. The spent carcasses drift downstream or settle among the rocks, their bodies beginning to decompose. From the fertilized eggs hidden in the gravel, new life will carry forward the legacy of the parents who gave everything for the next generation. The death of salmon after spawning is not an end, but a beginning for the entire ecosystem around them. Salmon carcasses deliver a massive pulse of marine nutrients to freshwater streams and the surrounding forests. These nutrients, including nitrogen, phosphorus, and carbon, were accumulated by salmon during their years at sea. By returning to their natal streams and dying, salmon transport these ocean-derived nutrients deep inland. This process is known as nutrient cycling, and it is one of the most important ecological functions in the Pacific Northwest. Over 100 species of animals directly benefit from the nutrients provided by spawning salmon. Bears are among the most visible beneficiaries, gathering at salmon streams to fatten up before winter hibernation. Grizzly and black bears catch salmon from the stream, often carrying them into the forest to eat. Bears are highly selective feeders, often consuming only the most nutrient-rich parts of the fish and leaving the rest. The discarded remains decompose on the forest floor, releasing nitrogen and phosphorus into the soil. This fertilizes the growth of trees and plants along the stream banks, creating a richer, more productive forest. Studies have shown that trees near salmon streams derive up to 70% of their nitrogen from salmon carcasses. These trees grow taller and faster than trees in comparable areas without salmon runs. Bald eagles also gather in large numbers during the salmon spawning season, feasting on carcasses and weakened fish. A single eagle can consume up to 1 pound of salmon per day during the peak of the run. Otters, mink, crows, ravens, gulls, and many other birds and mammals feed on salmon carcasses throughout the season. Even the smallest organisms benefit from the salmon bounty. Insects and aquatic invertebrates feed on decaying flesh. The insects that feed on salmon become food themselves for fish, birds, and amphibians living in the stream. The nutrients released from salmon carcasses also feed the aquatic plants and algae that form the base of the stream food web. Young salmon, fry, and parr benefit directly from the nutrients left by the previous generation of spawners. The growth rate of juvenile salmon is higher in streams with abundant carcass nutrients. This means that the death of adult salmon literally feeds and strengthens their own offspring. Salmon carcasses also contribute to the physical structure of the stream environment. The bones and organic matter become part of the gravel bed, creating habitat complexity for aquatic life. Wolves, though less commonly associated with salmon, also feed on them in some coastal regions. Even the vegetation along stream banks grows differently because of salmon, with denser undergrowth and larger leaves. This vegetation provides shade that keeps stream waters cool, which is critical for salmon egg development. The roots of streamside plants stabilize the banks, reducing erosion and maintaining water quality. In this way, salmon act as a keystone species, shaping the entire ecosystem around them. The connection between salmon and the land is so profound that scientists describe it as an artery pumping life from the ocean into the heart of the continent. Hidden beneath the gravel of the stream bed, the fertilized eggs begin their development in the cold, clear water. Protected by their gravel covering and constantly bathed in oxygen-rich flow, the embryos grow steadily. Over the weeks that follow, the tiny fish develop eyes, a backbone, and a beating heart visible through the transparent shell of the egg. When the time is right, the eggs hatch and alevins emerge, each carrying a bright orange yolk sac that provides their first nourishment. The alevins remain hidden in the gravel, not yet ready to face the world above. During this time, they are completely dependent on their yolk sacs, absorbing nutrients as they continue to grow. After several weeks, the yolk sac is fully absorbed and the young fish emerge from the gravel as fry. The cycle of life begins again, precisely as it has for millions of years. These fry will spend the next months or years in the stream, feeding, growing, and avoiding predators. They will develop their paw marks, their camouflage stripes that help them blend into the gravel and shadows. They will undergo smoltification, the transformation that prepares them for life in salt water. They will migrate downstream to the ocean, where they will feed and grow into powerful adults. And one day, driven by the same homing instinct that guided their parents, they will return to this very stream. The continuity of this cycle is remarkable. Salmon have been returning to the same streams for thousands of years. Genetic studies show that individual salmon populations are adapted to the specific conditions of their home watershed. Each population is uniquely suited to its own river's temperature, flow patterns, and timing of seasonal changes. This local adaptation means that salmon are finely tuned to their environment in ways that scientists are still discovering. The salmon life cycle connects the smallest stream to the vast ocean, linking ecosystems across thousands of miles. It connects the deepest ocean waters to the tallest trees on the forest edge. It connects bears, eagles, insects, and trees in a web of life that depends on the return of the salmon each year. The health of salmon populations is an indicator of the health of entire watersheds. When salmon thrive, the rivers run clean and cold, the forests grow strong, and the wildlife flourishes. When salmon decline, the effects ripple through the entire ecosystem, from the forest canopy to the ocean floor. Salmon face many challenges in the modern world, including habitat loss, dams, climate change, and overfishing. Dams block migration routes, preventing salmon from reaching their spawning grounds in many river systems. Warmer water temperatures due to climate change stress salmon at every stage of their life cycle. Despite these challenges, salmon continue their ancient journey, adapting and enduring as they have for millennia. The story of the salmon is a story of persistence, of life finding a way against tremendous odds. Tonight we have followed the salmon from gravel to ocean and back again, a journey that reminds us of the deep connections that sustain life on this planet. As our story ends, let the quiet ideas settle softly. Your body can continue to relax, breathing slow and steady. If sleep is near, let it arrive naturally. Thank you for spending this moment here on Cozy Sleep Time. Return anytime for another peaceful journey. Good night.